Okay, so today's lesson is part 2 of our lesson on arithmetic sequences. So this is what the first page of your notes looks like. We got through everything and we stopped when it was time to write explicit formulas. So we just did recursive formulas. We're going to go to this slide where we talk about explicit formulas. And explicit formulas you actually know how to write already. The format looks a little different, but this is what we've been doing when we've been doing patterns in the formulas. So an explicit formula is a function rule that relates each term of a sequence to the term number, which we usually refer to as n. Okay, so for this sequence, 70, 77, 84, 91, we're going to write both a recursive and an explicit formula. So we're going to find the 5th term and we're going to find the 15th term. So the recursive formula is not very handy. Bless you. It's not very handy for finding terms that are really far out. Like if we wanted the 100th term, we'd have to know the 99th term to use the recursive formula. Whereas if we have an explicit formula, we could find like the 5,000th term easily with the explicit formula. Okay, so first let's write a recursive formula for this. First of all, this is an arithmetic sequence. So who can tell me what the recursive formula would be? Athena? It's plus 7, so how would we write that out as a recursive formula?
A of n equals A of n minus 1 plus 7.
Plus 7. Good. That's our recursive formula. Recursive formula is really pretty easy to figure out as long as you have this format memorized. Or I don't have the poster up yet. I meant to put that up over the weekend, but I have a poster that lists the format, so you'll have it there to look at. Okay, to do the explicit formula, we're going to make a table just like we did before when we were writing formulas. We're going to use n and a of n instead of x and y. And in the n column, we're just going to list the number of the terms. So if the sequence starts with 70, that's term 1. So we have 4 terms, 1, 2, 3, 4. And then a of n will be 70, 77, 84, 91. Now, in an arithmetic sequence, it's always going up by addition. So we don't have to do any complicated formula finding. We have a change of plus 7 each time. So our change is 7. What would our start value be? Our value when x is 0. Emma?
63.
63. Good. So our start is 63. Yeah, that's correct. So remember we write the equation. We used to have y equals change times x plus start. Well, now we've replaced y with a of n, and we've replaced x with n. But everything else is still the same way. So when we're writing an explicit formula, we end up with a of n equals the change, which is 7, times n plus start. So see what I mean? That you already know how to do that. It's just a matter of using a of n and n instead of y and x. Okay, then it asks us to find the 5th term. Now the 5th term would be really easy to find using the recursive formula, because we know we're just adding 7, right? So what would the 5th term be? Gabby? What's that? 98? Good. The 5th term, which we could refer to as a of 5, is 98. To find the 15th term, we are not going to want to use the recursive formula because we'd have to just kind of make a list and add 7 every time, and we don't want to do that. So a of 15, we're going to use the explicit formula. So we're going to do 7 times 15 and then add 63. Someone want to do that and tell me what you got? 7 times 15 from this formula plus 63. What did you get? 175. Good, that's correct. I think. Let me check here. 7 times. 70.
Plus 60.
No.
I have
Should be
160.
168, yeah. Let's see, because you'd have 105 plus 63, yeah, 168. Okay, any questions about this? Okay, the rest is just practicing writing recursive. So if you didn't quite get the recursive from last time, we're going to get a little practice with that. And then we're going to get some practice finding. I just picked the 9th term kind of randomly. So we're going to go through each of these together. You will have class time to work today and also time to ask me questions if you need to. So we're first going to write the recursive formula because that's the easier one to write. Okay, and I'm going to use the cards to call in people randomly here. Here's Adam. What would the recursive formula be for that sequence?
A of n equals A of n minus 1 plus 6.
Excellent. That's it. Now I'm going to set up a table to find my explicit. 1, 2, 3, 4. That 2 kind of looks like a 3. 2. There we go. 3, 9, 15, 21. Some of you may be able to do the explicit formula without drawing the table, so actually drawing it is going to be optional. Zane, can you tell me what is the change according to the table?
Add 6.
6, good, or just positive 6. What would our start value be?
-3.
Good. So what would my explicit formula be?
A of n equals 6 times x minus 3.
6 times n instead of x. Good. 6n minus 3. Okay, and then it asks us to find the 9th term, so we're going to find a of 9. Rosa, what would a of 9 be?
Yeah,
51 is correct. Okay, number 2. TJ, what would the recursive formula be?
A of n equals A in minus 1 plus 12.
Good. Okay, now the explicit formula. Liz, would you like to draw a table to find the explicit formula, or do you want to try it without? You want the table. Okay. So we'll do n. A of n, 1, 2, 3, 4, 23, 35, 47, 59. Liz, what's our change? And what's our start? 11. So what would our formula be? Uh-huh. Good. Jocelyn, can you find a of 9 for us? You would do 12 times 9, and then add 11. 119, good. Okay, let's pause here and give you a chance to try 3 and 4 on your own, and then we will come back and talk about it. Just a caution with 3 and 4, or kind of a heads up, it's okay to use decimals because it can go up by a decimal amount, and if it goes down, you would just want to make your change be negative. Okay. So a of n equals a of n minus 1 plus or minus something. Recursive formula always starts like this. So recursive always starts with a of n equals a of n minus 1 plus or minus something. What do you do to get from one term to the next?
You add 0.5.
Yes, you add 0.5, so that's what goes to the end. That's how easy it is to write a recursive formula. It's the same thing, you just have to plus or minus whatever is going on in your sequence. Okay, explicit formula. Sam, what did you come up with?
A of n
0.5 n plus 6.8. Good, that's correct, because our change, we can see from the recursive formula, is 0.5, so that's what we put in front of the n, and then our start we find by subtracting our change, which is 0.5, so we get 6.8. Okay, number 4. Zan, what's the recursive formula? What's that? Minus 9. Yeah, I didn't hear your last part. Okay, good. Minus 9. So, explicit formula, Zoe. Okay, volunteer for the explicit formula on that. Emma?
Change is minus.
Okay, so change is minus 9.
Start is 106.
106, good. So in this case, since we're going, our change is minus 9, we have to add 9 to get to the term previous. Okay, so my formula?
A of n equals negative 9n plus 106. And then I did a times.
Oh, that's right. I didn't ask you for a of 9. So what did you get for a of 9?
I didn't get a of 9. I did a of.
Oh, you just picked one to do. Okay, so you did a of 4. Let's go with that. A of 4. Whoops. So she found a of 4 instead of a of 9. What did you get?
Equals 70.
70?
Yeah.
Yep, that would be right. Okay, what if we found a of 9 for this? What would a of 9 be? Did anyone get that? Sophia? 25. That's correct. Let's zip back over to our last one. What's a of 9 for this one? Hannah? Good. 11.3. Okay, any questions about this? Okay, there's one further thing I want to just briefly look at. In the textbook, if you would open your textbook to page 279, there are a couple problems in here. If you read the textbook explanation, it's really tricky, but it's not very hard to do based on the way that we just did things. So if you would open to page 279, I want you to look at, we're going to do number 38 together. So number 38 asks you to write an explicit formula for each recursive formula. So it starts with a recursive formula. A of n equals a of n minus 1 plus 12. And it also tells us that our first term, a of 1, equals 12. We need to turn that into an explicit formula. How do we do that if we don't have the terms listed? What does the 12 represent in the recursive formula? Liz? Well, a of 1 is 12, but this 12, this 12, what does this represent? That we're adding 12 each time. So that's our change. We can get our change from that. Whatever we're adding or subtracting is our change. To find our start, does anyone have any ideas what our start would be? Athena? It would be 0, because a of 1 is 12. We know we're going up by 12, so to find a of 0, we have to subtract 12, and we get 0. So our start is 0. So our explicit formula would then be a of n equals 12n. And if you look at, if the answers are in the back of the textbook, they're going to list it a little bit differently. They do some really strange way of listing the explicit formula that's unnecessary. The answer that you'll see in the back of the book will look like this. if this one is in the back, and it's only certain ones that are, it will say 12 plus n minus 1 times 12. And they do it this way with the term on this side of the n minus 1. I think the book is looking for an easy way to write these formulas. This is the same as this, because if we do 12 plus, if I distribute this 12, I have 12n minus 12. 12 minus 12 is 0, so I'm ultimately left with a of n equals 12n. Our explicit formula is a whole lot more direct and makes a whole lot more sense than writing it this way. I think they're trying to, they have some formula, if you kind of read the instructions, to go from one to another, which is confusing and unnecessary. So I would not use the textbook explanation on this. Okay, next one I want to look at together is number 42 from the textbook. Because number 42, they start with the explicit formula that looks more confusing than the way we do it. We have a of n equals 5 plus n minus 1, whoops, see there, times negative 3. And you are to write a recursive formula. The only thing you need to know for the recursive formula is the change. We're just interested in what it goes up or down by. So the recursive formula is going to be a of n equals a of n minus 1 plus or minus something. What would the change be according to this? I am going to use a parenthesis there. That's not subtracting 3, it's times the negative 3. What would the change be? Zane?
Negative 3.
The change would be negative 3. So it's just minus 3.
It's regular.
Yeah.
Is it a regular 3? Did I copy that wrong?
That's what he said.
You're right. Okay. So it should be a regular 3. Let me go back and fix that. That's why we didn't need a parenthesis there. Regular 3, so it would be plus 3. Okay, so you're just looking, if we were to distribute this 3, we would have 3n, so that's what would be in front of the n. Any questions about this? Okay. Your assignment then